The single agent architecture is or showed to be rather easy to set up. You don't have to think about, okay, how do I separate my full workflow? I just give all the tools and all the info necessary to solve it to that one single agent. You have to admit, though, that the prompting gets a bit more complex, and it can be a bigger prompt, and it's not nicely separated. However, yeah, it has this simple architecture. It's easy to set up, and you have this centralized reasoning, and it fulfills the job. However, it can have at some point, and that's a major disadvantage of single agents. When the problem gets too complex, you can run into limitations of that architecture simply because yeah, it has too many information to process and can get confused by that. Similar to a human, if you give them all the tasks, it might confuse a single person. And so the single agent it can be effective for certain tasks, but if complexity rises, I have to admit probably Linen's approach is slightly better.
So when you say the complexity rise, is that just like when you have like a longer conversation, like the context window that the agent is like handling at the time? So if you're having
Yeah.
like multiple questions you're asking the agent,
It
that's when it starts to fail, basically.
it's a combination basically. So when you have your system and you give this initial starting prompt basically, and it's already quite long, the agent has to navigate it, and yeah, the longer the prompt and the more info is in it, the more complex it gets for the agent. And adding to that is when you have a long conversation history in a single session with that agent. You can see that it will reach certain limits at some point because everything is loaded onto that single agent and loaded onto that yeah, happening in that area of that agent, and also the LLM of that single agent is is loaded more heavily, you could say, compared to a distributed system where I can distribute the load about on different agents.
Right. Okay. Okay. Yeah. And then I'm seeing this point here on lower latency and fewer handoffs. I hadn't realized that was something that, yeah, I just didn't come to me. Like if there's a team of agents, it makes sense.
Mm.
There's like a bit of time
Mm.
between, I guess, communication, handing off data and stuff like that. I don't know. Could you expand on that a little bit more? I'm just curious. I
Yep.
don't know if we
Yeah,
touched on that at
you can
all.
basically um, think of it as the same like overhead that you have in human teams, but on
Yeah.
a different scale. Like when I
Right.
have finished a task, I hand it over to my colleague, and he can work on it. Agent systems will also have like this slight overhead, like you have to communicate between different agents, so it might have a little bit of a lower latency, but the comparison to a human system is lacking a bit because the agents don't wait to start with something. They start straight
Right.
away, so that latency is it's a slight advantage of that single agent because it's just one agent just plugs into different tools, and there cannot be like a miscommunication of some sort. It's just that one agent that can be confused. Yeah.
Right. Okay. Okay. Yeah. That makes sense. Thank you. I don't know, Lillian, do you have any points on like, is there anything that you learned from the team of agents? Anything that kind of like, I don't know, stood out to you or anything?
I think one important point is the prompting. I feel that with multiple agents, it's simpler. Yeah, it's simple to just creating the prompting. Yeah, instead of having just one big prompt with all the information, this is a great point. And yeah, even though the single agent was a bit faster to provide the answer for the same example that we showed to you, yeah, when we increase the complexity, considering more inputs and the longer prompt, and yeah, have a challenge which is more complex, then the multiple agents can fulfill better.